So in math, when you're doing coordinate geometry, anything to do with an XY plane, it's important to remember that there's a difference between the position, a number that represents position, and a number that represents distance. So for example, if I were to, on this coordinate plane, locate that point there, that point is at a position of pi over 2. It happens to have a distance of pi over 2 from 0, but the position is pi over 2. Now, notice that between these 2 points here, that represents a distance of pi over 2 as well. That's a distance, okay? That's very different than locating, I'm going to do this in a different color, locating this position of pi over 2. That red dot represents the position of pi over 2, and that black line represents a distance of pi over 2. They're two very different things. And if we just pause for a moment to just think about it, it's very easy to tell them apart. But it's important we understand that there needs to be a distinction between the two. Now, some of the big ideas that we could use to our advantage is this idea of symmetry, middle, and average. So we have a formula to find the middle or average. It is the start and end divided by 2, or 2 scores. If we have 2 different scores, we can add them together and divide by 2 to get an average. This happens to work also for middle position. Okay, locating the position or location of a middle line. So how does this relate to trig? Well, in trig, since trig functions generated by circles, they have 4-part symmetry, and they can be divided into 4 equal quadrants. And so I've shown here that, so in our sine graph, we have a starting at 0, ending at 2 pi, and we can locate the middle line. We can divide this into 4 quadrants by finding the middle, which is that purple line. And then furthermore, we can divide into quadrants by taking the middle line and the red line and finding the middle, which is a green line. And we can find all 4 quadrants. And notice that we have our 4 parts of our quadrants. Our first quadrant, second quadrant, and again, these are symmetrical parts because these are all the same shape. Okay, they just are oriented differently depending on the quadrant. So there's our 4-part symmetry. Now, if we want to find the positions, the location of where the quadrant boundaries are, one strategy is to add just a quarter period. Okay, so we can start at some position. For example, we can start at pi over 2, and we can add a quarter period, or pi over 2, to get to the quadrant boundary. Okay, that's definitely one way we can do it. Now, when the numbers become awkward, it's sometimes a little bit hard to do. And again, we have to be careful because we're dealing with a position, pi over 2, but we're also using a displacement or a distance of pi over 2. And we have to make sure we don't mix up the two. But I think an easier way to do this is to use the middle formula. So we have this midpoint, or calculating the middle position or average position. We can use the start and end and divide it by 2. So in this case here, if I want to find that purple line, what I can do is I can do this. I can say that the middle, okay, is equal to, well, I'm going to find the middle between the 2 red lines. It's going to be 0 plus 2 over pi divided by 2, and that gives me the middle line at pi. Okay, and that represents a position or a coordinate. Okay, and that locates the coordinate. It's not a distance, but a coordinate of pi. If I then want to divide it into quadrants, I can take that, I can find the quadrant. So Q1 can be found by taking in fact, I'm going to do the third quadrant here. I'm going to take the middle line, which is pi, plus the end position, which is 2 pi, Dividing it by 2 is going to give me the quadrant boundary, which is 3 pi divided by 2. It's going to be 3 pi over 2. Okay, and notice that that is the correct position of the middle line that divides the quadrants from quadrants 2, 3, and 4. So this idea of finding middle using an average to find middle is very useful, especially for these circular functions, because circles have this 4-part symmetry, and we can easily divide it in half and half to get the 4 quadrants.